we just want to say, Boni, thank you very much for taking the time and joining us. And we all expect to hear your talk. So good luck. Thank you.
Okay, I'm trying to share my screen. Let me see. Can you see my screen?
Yes.
Cool. So let's get started. Well, many thanks. Thank you very much for having me and giving me the opportunity to talk in this excellent conference. I'm going to talk about browser automation APIs. In particular, I want to share my point of view of these four APIs: Selenium, Cypress, Puppeteer, and Playwright, which are four of the most popular APIs we use to control browsers. Of course, there are more. There are plenty of tools. In here, there is a link you can visit to get more resources and tools devoted to browser automation. But today, I want to talk about these four tools, starting with Selenium. Well, Selenium is, I suppose, very popular for many of you. And Selenium WebDriver, which you usually know simply as Selenium, as I see it, it's a multi-language browser automation library. Right? So it's a library, it's an API we use to control browser programmatically. It has been maintained by the Selenium project since 2004, with next month, by the way, the 20th birthday of Selenium. So it's well, more or less old project. And today it's officially Java, JavaScript, Python, .NET, and Ruby. So we can use Selenium to control any browser with a driver compliant with the WC3 WebDriver specification. This is a deep sentence I'm going to explain with the architecture in a couple of slides, because this is the whole core of how Selenium works. So this is in 3 minutes what is Selenium in my point of view. But also, I believe it's very important to say explicitly what is not Selenium. Oh, well, for me, Selenium is not a testing framework. And Selenium is not even a testing library. I suppose this can be a surprise for some people, maybe, because many of the developers think that Selenium is about testing, but it's not completely true. So, well, I'm going to explain myself now, because you may ask a couple of questions, for example, but is it possible to do testing with Selenium? Well, of course.
We see the PowerPoint, but not the presentation itself.
Ah, okay. That's very bad. You can. What can you see? This.
Yes, this one is.
Ah, okay. Sorry, that's very bad. Okay, I'm going to do that. I'm going to do this way then. Right? It's okay? Sorry, because, well, yeah, well, let's do that. Let's do this way. This is the slide you have missed now. I said, well, this is what is Selenium, right? By the way, the slides, you will get the slides, right? So you will get all the links I'm going to provide you. You will get them. But in this, I was explaining what is Selenium, right? And I was saying what is not Selenium, right? That's the way it works. Right? Selenium is not a testing framework for me. Selenium is not a testing library. We can do testing with Selenium, of course. And the other question is, what's the difference between library and framework? Because I say Selenium is not a testing framework nor a testing library. So you can ask, what's the difference? Because we developers many times use library framework, but I'm not completely sure that many times we understand the difference. And since I work as a professor at university, I tend to define terms clearly, or as clearly as I can. And in here, I have my own definition of, well, my own point of view of library and framework. So for me, a library is a collection of code that we developers can call using an API to solve a given problem, right? We do this all the time. So in this, there is an analogy. Sorry, because I lost the animation, but well, you can see the whole picture of my slide now. But in here, there is an analogy. Imagine that an API is a bottle of paint, and the canvas is the software you are developing. So you are free to use your API, your bottle of paint, to develop your software, to paint whatever you want. On the other hand, a framework, for me, it's a library. So it's, again, a collection of code that you use to solve a problem through an API, but also provides you some structure for developing your software, some design you need to meet. And in this analogy, you have the same bottle of paint, but again, also you have the frame, right? Because it's a framework, the bottle of paint comes with a frame you need to use for develop your software. So, well, you can select your color because you have the API, you have the bottle of paint, but you need to meet the framework. You need to use the frame. So that's the difference for me between library and framework, right? And, well, again, Selenium, for me, it's a library. It's not a framework, right? We are free to use this browser automation API in the way we want. And in this slide, I want to present the architecture. I believe this is something that we developers skipped when using Selenium. We go directly to the point and browser automation to use Selenium API, but maybe we skip this part and forget a deep understanding of Selenium is important. So, well, on the one hand, we have the script we use using the Selenium API, right? On the other hand, we have the browser, which connects to the web under test typically. But in the middle, there is an important piece, which is the driver. A driver is a binary file that somehow which connects the script using the Selenium API with the browser. And this communication is done through a standard W3C specification called WebDriver. Right? This is a standard which browsers need to meet, in this case, through this piece called driver. Right? And this is the whole proposition of Selenium, using standards that browsers need to meet because are promoted by the WC3. So, next slide. What do we need to use Selenium? Well, as I said, Selenium is a multi-language browser automation library. So the project setup is going to be language specific. It's not the same using Java or using Python or using Ruby, for example. So, for example, for Java, we can use Maven Gradle to give an example. Then, second, what we need? Of course, we need a browser. But not only the browser, we need the browser and the driver. We need Chrome driver for Chrome, Gecko driver for driving Firefox, and so on. So someone needs to manage this driver, downloads, configure, and put in my machine or whatever machine I'm using to control the browser. So, well, for many years, Selenium was said that it's not a library of a tool which solve this problem. So for that, it appeared the managers, these libraries, would help us to solve this problem in an automated fashion, like WebDriver Manager, which is the library which I created for Java. Then other similar managers appeared for Python, JavaScript, also managers, WebDriver managers, even WebDriver Manager for .NET. And nowadays, we have this concept directly in the Selenium project. I don't know if you know this, but now we have Selenium Manager, which is the same concept, even more powerful, because not only manage drivers, but only manage browsers. So Selenium, out of the box, in the latest version, allows us to manage browsers and drivers automatically thanks to Selenium Manager. If you don't know this, I recommend you to take a look to the documentation, because now using Selenium is easier than ever. It's basically relaying in Selenium Manager to manage the driver on the browser. So let's move to some code. I like to use code because, of course, we are developers, we are testers, and we need to see code. And this presentation has plenty of code. And here you can see a hello world in Selenium. By the way, in here you can see an URL. It's a GitHub repository. It's open. You can visit it. One contains all the examples, even more we are going to see in this talk. And if you want to compare by yourself these tools, Selenium, Cypress, Puppeteer, Playwright, I recommend you to take a look at this because it contains like, easy and quick examples to compare. So this is the hello world in Selenium. And as you can see, well, this is Java, right? You need to select, and well, I tend to use Java. And the thing is that in order to create a real test, now I am going to use Selenium for testing. I need Selenium, but I need more things. And typically I need a unit testing framework, for example, JUnit, right? You can see here that I am using the Selenium API here, but I am defining some methods with add tests, which for the non-Java developers is basically the way in which I am marking this method as a test. This is because I'm using a unit testing framework called JUnit. And this is the design that the unit forced me to do. That's because this is a framework and not a library. JUnit is a framework because I must follow this convention of using a test to mark this method as a test. Well, this is what happened before the test, and this is what happened after the test. So, well, in this example, I'm using also AssetJ, which is an assertion library. This is a assertion library I tend to use. And with this, I have a whole test using Selenium. And as you can see, I need 4 elements to create a complete test. So the last part of this Selenium presentation is about the ecosystem. What is something what is very, very, very important and well, remarkable in the Selenium community is that it's not only the API Selenium, the official API. There is projects maintained by people or well companies even that well enrich a lot this Selenium ecosystem. And in here I'm presenting all these 3 frameworks. Now this is frameworks based on Selenium, testing framework for well test automation. Based on Selenium, for example, Selenite, it's for Java. Nicewatch is for JavaScript, or Selenium Basis for Python. So my point is that Selenium is somehow the foundation layer for browser automation, and there's plenty of frameworks that you can use if you want advanced capabilities for testing. So let's move to the second technology, the second API I want to present today, which is Cypress. Cypress is a JavaScript end-to-end automation testing framework. Now it's not a library, it's a framework itself, right? And it has 10 years already. It has been created as a company, and it uses only JavaScript for automation, right? Browser, well, it can be used with many browsers, Chromium based, like Chrome It, Firefox Electron even, and WebKit, which is the engine of Safari. So again, we need to understand a bit about the architecture of Cypress to get the whole picture about this. And Cypress is very different to Selenium because in Cypress we are going to have a process implementing in Node, right? The Cypress process in the middle of the browser and the web application under test, right? And then in the browser we have a web application. In fact, it's called the test runner, which contains 2 iframes. And in one iframe, it's loaded the test, which is developed in JavaScript. That's the key, right? It runs directly on the test. And on the other iframe, we have the web application under test. So the thing is that test and web application under test run directly within the browser, right? Using JavaScript. And this, in my opinion, has pros and cons, right? The good thing about this is you have the test and the web application in the same event loop. So things like automatic waiting, it can be done very easily. But on the other hand, there are things that you cannot do with JavaScript. For example, iframes manipulation, it's not allowed, or tabs, open different tabs, it's also not allowed. But well, it's an interesting approach, but has its own, as usual, advantages and disadvantages. So in order to set up Cypress, you need, well, of course, Node, it's npm typically, and npx for open Cypress. Well, it's quite simple, I would say. And then the API, I have to say that it's very clear. It's very compact, it's very readable, and you can quickly create a test For example, this one is the hello world for me. It's the equivalent test I present for Selenium, but now for Cypress. And well, I have to say that Cypress is Mocha as a unit testing framework. So somehow we need to follow this guideline using JavaScript, use Mocha, and then understand the API to of course, automate my browser in the way I want. So this is about Cypress. So let's move to the third one, this Puppeteer. Puppeteer is a Node.js browser automation library. It's the same than Selenium. It's a library. This time it's not multi-language, it's for Node.js. And it has been created by the Chrome DevTools at Google since 2017. And the language they use is JavaScript or TypeScript. Browsers they can control Chromium-based browsers like Chrome and Edge, and it has some support experimental for Firefox. So, well, it's a Google project, so I suppose it's good news because typically these projects are good. And as usual, sorry, this is not a slide. I want to present the architecture in order to understand the details. The architecture of Puppeteer is quite simple, but also quite powerful. Originally, it was based on the CDP, which is the Chrome DevTool protocol, to control the browser. So it's basically a bidirectional communication directly in the browser with the browser and the script using the Puppeteer API. Of course, we have the web application and the test using HTTP or HTTPS. But the whole point of Puppeteer is use this protocol, which is the Chrome DevTool protocols, right? Which is, of course, provided by the Chromium project, like Edge or Chrome. Now, there is fresh news about this because the last Puppeteer release, like a month ago, something like that, also is supporting WebDriver by that. Right. I didn't mention when I talked in Selenium, but the WebDriver specification is being ported to what they call the BiDi, which comes from bidirectional, right? It's somehow the evolution of WebDriver using a WebSocket instead of HTTP and providing bidirectional communication between the two peers. So this is something that the Selenium project has promoted, and well, from a point of view, it's a very good news that this. Again, this is our WC3 specification. The Puppeteer is adapting this standard, right? I believe this is good for the whole community, have a standard that someone is promoting the WC3C. And in this case, Puppeteer is adapting, so it's good news, I believe. And the Rust release of Puppeteer, it's based in CDP, and also it has support to BiDi to control the browser. So, then, what do we need to set up a Puppeteer project? Well, typically we use npm to install Puppeteer, and internally Puppeteer, that's something that is also very appealing, will manage the browser for me. For example, in Chrome they use Chrome for testing, which is, by the way, the same that Selenium use in Selenium Manager. And then, well, as I said, Puppeteer is a library, so for implementing tests, we need all elements in the same way that we did in Selenium. Or, as an example, we can use Jest for implementing end-to-end tests, which is a JavaScript framework. So this is, again, the same or equivalent hello world, this time for Puppeteer, right? As usual, you have the code in this open repository. And as you can see, it's also very, very compact, very readable, very readable syntax, and well, there it is using this end-to-end test complete using Puppeteer, JavaScript, and Jest. It's unit testing framework. So let's move to the last API, which is Playwright, right? And Playwright, I define it as a multi-language end-to-end automated testing framework. Again, this is not a library, it's a framework. Somehow it's more complete, and it has comprehensive feature for testing. The history of Playwright is funny for me because it's maintained by Microsoft this time since 2020. but from people which originally was in Google and moved from Google to Microsoft. So, yeah. At the beginning, Playwright was an Node.js framework, so it was supported by JavaScript and TypeScript, and nowadays it's also supported in Python, .NET, and Java. So nowadays, Playwright is a full multi-language framework, testing framework. Now, the browser. This is the key of Playwright, as I see it. The browsers that Playwright supports is patched release of Chromium, Firefox, and WebKit, which means it's not exactly the same release that users use. It's a modified version of Chromium, which is the open source project of Chrome, as you know, Firefox or WebKit. So why is that? Well, the thing is that, yeah, sorry, okay. Can I continue? Okay. Playwright, I was saying that they use a modified version of different browsers, for example, Chromium. And they open somehow the browser processes with this modified version, and this event-driven access is used by the Selenium, the Playwright script, right? And with this architecture, they manage to control the browsers. So this, again, in my point of view, has pros and cons, right? I'm going to say this in the last slide, but well, we are not using the actual browser. Of course, it's more or less the same, but it's not exactly the browsers that the user use. So for starting a Playwright project, again, since this is a multi-language framework, the setup is browser is language specific. And for example, we can use NPM, which I believe is a very simple way because it has like a wizard to select the language and, well, the scaffolding, the parent scaffolding, and so on. So to complete this, we have again the same equivalent hello world in Playwright. As you can see, it's it's a very readable syntax as well. It has everything we need to create tests. We don't need any unit testing framework because Playwright itself, it's a testing framework. So well, I can say that it's quite convenient. So we are approaching to more or less the last part in which I compare the features. Well, this slide doesn't provide any information, but I compare one by one of the most relevant set of features, right? And I have to say that I found that these tools support most of the most common feature. I know element selection, weighting and screenshots, Windows handling. All of these features are covered in these 4 APIs. But of course there are differences, and maybe here is when we need to put our eye. Yeah, of course there are things that are not exactly the same in these 4 tools. Multi-language, for example, for me is Selenium and Playwright, but not Cypress and Puppeteer. The cross-browser for me, Selenium is the most complete, and the other one, as I say, they are experimental, but it's not complete. Automatic weighting is one of the most appealing features, I would say, and that's something that makes difference. The automatic weighting, it's not implementing not Selenium and not in Puppeteer because they are libraries, right? And automatic weighting can be tricky. But Cypress, because of this architecture based on JavaScript, and Playwright also implements automatic weighting, which is, I believe, a very, very appealing feature for testers. There are features that are impossible, for example, in Cypress because it's based on JavaScript. Tab handling, it cannot be done. Frames and iframe, you can do some tricks, but it's not complete. But on the other hand, Selenium, Piper, and Puppeteer, these features are out of the box. Console log gathering, it's also something in the middle. It's well, and the final set of features of this table, you can see that the last from assertions to component testing is not supported in Selenium, not Puppeteer, because by definition they are not testing framework, right? And this is testing a specific feature. So the thing is that Cypress and Puppeteer, they have the more testing specific features, but these are not covered in Selenium and Puppeteer. So here it is a complete example, not the hello world, which is a login that, well, this is in Gherkin syntax, typically using Cucumber, but you can use to define any test scenario you can do. And in here, well, many code here, but there is the implementation of this login page, automated by Selenium, Cypress, Puppeteer, and Playwright. As you can see, well, I know that this is a lot of code. We are not going to see the detail, but more or less, the script looks similar. The thing is that if the this login is slow, and that's something I implementing in the GitHub repository with a page that takes a loop to make the login, which is something that might happen. The difference is that in Selenium and in Puppeteer, we need to make an explicit wait, right? Because if not, when we are going to locate the element, for example, for the success login text, for example, well, if the login is slow, it's not going to be immediately, right? And that's something we need to explicitly wait for it, right? Both in Selenium and Puppeteer, and that's a key difference. But in Cypress and Playwright, you have this out of the box. This automatic waiting is out of the box. So since we have 5 minutes and I need to conclude, if you want, I recommend you to go to the repository and take a look at the code and see the difference between explicit waiting. So some summary. Well, in this table, it appears the whole explanation I have done. I'm not going to read everything. You have the slide. And let's go directly to the pros and cons. Well, as I said, the fork API has its own strengths. In my opinion, Selenium it's good because it's multi-language and it's completely based on standards, right? But the bad thing is that it's not a testing framework itself. Well, it's not about thing itself. It's the definition of this technology. But we cannot expect specific testing features within the library itself. This similar happens to Puppeteer. It has comprehensive automation features based on CDP and nowadays also in Bidi, but it's not a testing framework. By definition, it's a library. On the other hand, we have Cypress and Playwright. They are both testing frameworks. So they both contain advanced features for testing. The bad thing, well, but weak point in Cypress, there are operations that are not supported because it's based on JavaScript. And Playwright, well, the bad thing is, in my opinion, is we don't use actual browsers, but patches releases that they need for browser automation. So I believe that's it. Maybe we have 5 minutes, something like that, for questions, and I'd be happy to answer questions you have.
Well, Boni, first of all, thank you very much. Thank you very much. That was a very interesting talk. Unfortunately, we need to continue to our next talk because we are in a tight schedule. So I'm afraid we won't have time for questions. But I want to thank you very, very much for joining us.
Yeah, my pleasure. My pleasure. Thank you for having me. I hope you enjoy.
Thank you very much. Have a safe night.
Thank you. Yeah, thank you.